Okay, energy. So we already discussed in the video before this the relationship between heat and energy. And we know that we use energy all the time. Energy is the ability to do work. And then two ways that energy is classified a little bit further is through something called kinetic energy and potential energy. Kinetic energy is the energy of motion. So when you take a bike and you're cycling all the way up to the top of the mountain, you're using kinetic energy. Then when you're at the top of the mountain, you're staying still. That's stored energy. The energy stays within you. Then when you go back out, you're using kinetic energy. So if you were to pick up your phone from the table, at first it has stored energy. You can pick it up and you're moving it up, so it has kinetic energy. Then you're holding it there, so through that gravitational pull, it has a lot of energy in it, and that's potential energy. Then you drop it back down, and the potential energy is being converted to kinetic energy. So heat is the energy that's associated with the motion of the particles. An ice cube feels cold because heat flows from your hand into the ice cube, right? So we've kind of already discussed this before. You take an ice cube, you put it in your hand, eventually it melts. That's because heat flows from your hand into the ice cube. And the faster the particles move, the greater the heat is. So more thermal energy. So the energy associated with particles, atoms, and molecules is thermal energy. So as heat is added, the motion of the particles begin to increase until things melt. We know the units of energy. We've talked about how we have joules and calories and the different conversion factors between each. And we've done some practice problems. So here we're going to talk about specific heat. So every substance has its own characteristic ability to absorb heat. Certain substances can absorb more heat than others at varying temperatures or a specific temperature. So scientists kind of did experiments to figure out how different substances can absorb heat at a very certain temperature. The energy requirements for different substances are described in terms of a physical property called specific heat. This is how we figure out the energy that's needed at a specific temperature for different substances. This is specific heat of a substance. You can also see SH, or sometimes you see C lower subscript S. For a substance is defined as the amount of heat needed to raise the temperature of exactly 1 gram of a substance by exactly 1 degree Celsius. So exactly 1 gram of this, the heat that's needed to raise it by only 1 temperature. That's specific heat. So when we know the specific heat of a substance, we can calculate the heat that's lost or gained. So how much heat was lost or gained from that ice cube melting into my hand. If we know the mass and we know the initial and final temperatures, I can use something called a heat equation. So heat, which can be in calories or joules, so I'm going to say calories right now, is equal to the mass of whatever substance in grams times the temperature change, which is usually delta. The triangle delta means change, times my specific heat, which is in calories, gram degrees Celsius. Specific heat can also be in joules per gram degrees Celsius. An abbreviated version of writing this is Q is equal to MC delta T, MCAT. Q is your heat, which is in joules or calories. M is your mass, which is in grams. C is your specific heat, which is in calories per gram degree Celsius or joules per gram degree Celsius. And delta T is T final minus T initial in Celsius. So T2 minus T1. So if I wanted to know how much heat was gained by the ice cube in my hand, I would take the temperature of the ice cube first, the mass, then place it into my hand. And after it melted, take the temperature again. Then I have the mass, the temperature change, and I know the specific heat, so I can figure out how much heat was lost. Let's do an example. Use the heat equation to calculate the energy in joules and calories for each of the following. So we're going to walk through one of these. We want to heat 25 grams of water from 12.5 degrees Celsius to 25.7 degrees Celsius. The specific heat of water, when it's not given to you, you can always look up. It's 4.18 joules per gram degrees Celsius. Okay, so what I like to do is kind of pick things apart and write what I'm given. So I'm given mass, 25 grams. I know my specific heat, 4.18 joules per gram degrees Celsius. I have a temperature change from, so that's my T1, T initial, 12.5 degrees Celsius, to my final temp, T2, 25.7. And I want to calculate heat, energy. So I want joules and calories. So I have to do it once and then convert to the other unit. Doesn't matter which unit to start with, but what I like to look at is that I have my specific heat in joules, so I'm going to first solve for joules. So when you have multiple of these factors, so temperature, mass, and energy, you're going to look for your Q equals MCAT equation. So Q is equal to the mass, 25 grams, times the specific heat, times your change in temperature. Now, here we did not have to do any conversions at all. However, if your temperature was given to you in Kelvin, your mass was given to you in kilograms, anything was given in some other kind of unit, you would have to convert. My little piece of advice is to convert all your units to always match your specific heat. Here we didn't have to do that. So then let's plug it all in. So 25.7 minus 12.5 times 4.18 times 25. I get, for my energy in joules, 1,379.4. Now, based off of what I'm given here, how many sig figs do I want? So these were the numbers I was given. 3. So then Q is equal to 1,380 joules. Well, I want to do one more thing. I want calories. So what is my conversion from joules to calories? Look that up. 1 calorie is equal to 4.18 joules. Now, since this is a definition, it's an exact number and not going to be used when doing significant figures. We will still want 3. So then I have 1,380. Is that the number I should use? No, you want to go back and use your number with the more digits that you have to be more precise. 1,379.4 joules times 1 calorie, because that's what I want, over 4.184 joules, because that's what I'm trying to get rid of. And then how many calories does that give me? I get 329.68 calories, and I want 3 sig figs, so 330 calories. Whoops, is that 3 sig figs? That's 2, so I can add a little period here at the end to make it 3 significant figures. Now, you can use this equation, the Q is equal to MC delta T, to solve for anything. You could solve for the heat, you could solve for the mass, you can solve for the specific heat, you can even solve for one of the temperatures by always writing out that it's T2 minus